Bismillahir Rahmanir Rahim. All right, so this is part one of lecture number 1.5 of International A Level Edexcel P3. Okay, in the previous lecture, we started with the topical past paper handout of P3, chapter number 1, Algebraic methods. Okay, we solved from question number 1 till question number 4, and then I gave some homework as well in the WhatsApp group. Okay, as you are already aware. And now we have some more questions from this handout. First of all, we have question number 13, which is June 2012, C3, question number 1. Okay, so the question is saying that express 2 multiplied by 3x plus 2 upon 9x square minus 4 minus 2 upon 3x plus 1 as a single fraction in its simplest form. All right, so first thing first, we need to factorize the denominator over here. Okay, so as we can see that we can rewrite this expression as a difference of squares, meaning 3x whole squared minus 2 squared. Okay, so here you have the form of a square minus b square, which will be factorized as a plus b multiplied by a minus b. So therefore, the factorized form is 3x plus 2 multiplied by 3x minus 2. Agreed? Okay, so we can rewrite the fraction in this form: 2 multiplied by 3x plus 2 divided by 3x plus 2 into 3x minus 2 minus 2 upon 3x plus 1. And as we can see that 3x plus 2 and 3x plus 2 got cancelled out, got eliminated, and therefore now we have this thing 2 upon 3x minus 2 minus 2 upon 3x plus 1. Okay, and now we are going to express this as a single fraction, meaning we need to take the LCM first. And as we can see that 3x minus 2 and 3x plus 1 are completely distinct. Okay, कुछ भी repeat नहीं हो रहा, so no factor is being exactly repeated. So LCM would be just the product of these two expressions. Okay, so LCM is supposed to be 3x minus 2 multiplied by 3x plus 1. All right, so you need to ask yourself by what term you multiply 3x minus 2 such that you get this complete expression. 3x minus 2 multiplied by 3x plus 1. Obviously, you need to multiply it with 3x plus 1. So the numerator 2 will also be multiplied by 3x plus 1. Okay, the numerator 2 will also be multiplied by 3x plus 1. The screen is moving a little bit slow. I don't know why. This 2 will be, I'm going to repeat this again, 2 is being multiplied by 3x plus 1 as well. Okay, so in the numerator we have 2 multiplied by 3x plus 1, and then we have a subtraction sign. Okay, and we need to ask ourselves by what term we multiply 3x plus 1 such that we get this expression completely. Obviously, we need to multiply it with 3x minus 2. So here the numerator will also be multiplied by 3x minus 2. I hope the speed is good now of the screen. Okay, so minus 2 times 3x minus 2 over here. Okay, because we have the subtraction sign as well. So the numerator would be something like this. And now we are going to expand the numerator and then simplify. So 6x plus 2 minus 6x plus 4. So 6x minus 6x got cancelled out, and 2 plus 4 is 6. So 6 divided by 3x minus 2 multiplied by 3x plus 1. This is supposed to be our answer. All right, so this was the solution of handout question number 13. So now let's move on to the next question. So up next, we have handout question number 15, which is June 2013, C3, question number 1. Okay, so the question is saying that given that 3x raised to the power of 4 minus 2x cube minus 5x square minus 4 divided by x square minus 4, this is exactly identical to ax square plus bx plus c plus dx plus e upon x square minus 4, where x is not equal to plus minus 2. Okay, because if we put x is equals to plus minus 2 in the denominator, so the function would become undefined. This expression would actually become undefined. Okay, so find the values of the constants a, b, c, d, and e. Okay, so first thing first, we have a quartic polynomial. Okay, we are going to write it in a strict sequence. Here we have an improper fraction given to us, and this is the mixed fraction form. Okay, so polynomial is being divided by a divisor, which is exactly identical to quotient plus remainder over divisor. Okay, so this is basically the whole scenario. So find the values of the constants a, b, c, d, and e. So first of all, I'm going to write this polynomial in a strict sequence: 3x raised to the power of 4 minus 2x cube minus 5x square and then plus 0x, meaning the coefficient of x is 0 because in the polynomial the term in x is not existing. But when we are using this approach, we always write the polynomial in a strict sequence. I mentioned this thing many times in the previous lectures as well. Okay, and then we have minus 4. Okay, and this is divided by x square minus 4. So again, a strict sequence: x square plus 0x minus 4. All right, so we need to ask ourselves by what term we multiply this x square such that we get 3 multiplied by x raised to the power of 4. Obviously, you multiply it with 3x square so that 3x raised to the power of 4 comes exactly underneath. And then this 3x square is multiplied by 0x, so conceptually 0x cube. And then this 3x square is multiplied by minus 4, so minus 12x square. But as you can see that the elimination is not happening. But when we multiply this expression with a minus sign, so the sign of each and every term gets changed. So 3x raised to the power of 4 minus 3x raised to the power of 4 got cancelled out. Okay, and minus 2x cube will be mentioned as it is. Okay, and minus 5x square plus 12x square, this will give you 7x square, and 0x will be carried forward as it is. Then we need to ask ourselves by what term we multiply x square such that we get minus 2x cube. Obviously, we multiply it with minus 2x such that we get minus 2x cube underneath minus 2x cube exactly. And then this minus 2x gets multiplied with 0x. So conceptually speaking, minus 0x square. And then this minus 2x gets multiplied with minus 4. So conceptually positive 8x. बज़ाहिरन तो एलिमिनेशन नहीं हो रही और वो हो भी नहीं रही होती as the elimination is not happening. But when we multiply this expression with a minus sign, so the sign of each and every term gets changed. And our intention here is to eliminate this cubic term. So minus 2x cube plus 2x cube got cancelled out, eliminated. And then 7x square plus 0x square, meaning 7x square as it is, and 0x minus 8x, which gives you minus 8x, and this minus 4 is carried forward as it is. All right, and then we are going to continue with the comparison in the same way. We need to ask ourselves by what term we multiply x square such that we get 7x square over here. Obviously, you multiply it with 7. So 7x square comes underneath exactly 7x square. And then this 7 is multiplied with 0x. So conceptually, this gives you plus 0x. And then 7 multiplied by minus 4, this gives you minus 28. And as we can see that the elimination is not happening, but when we multiply this expression with a minus sign, so the sign of each and every term gets changed. Okay, so 7x square minus 7x square got cancelled out, and minus 8x minus 0x, which leaves you with minus 8x. And minus 4 plus 28, this gives you positive 24. So minus 8x plus 24 is the remainder. Here we are going to stop. Okay, so we have expressed this improper fraction which was given to us in the question. We are going to express this improper fraction in a mixed fraction form, which is quotient plus remainder divided by divisor. As simple as that. So quotient is basically 3x square minus 2x plus 7, and the remainder is minus 8x plus 24, and the divisor is x square minus 4. Okay, so therefore A is equals to 3, B is equals to -2, C is equals to 7, D is equals to -8, and E is equals to 24. We are just making a comparison with the required form and mentioning the values of the constants A, B, C, D, and E. Okay, so in this way, we have attempted this question. I hope you have copied down the working. So now let's move on. So coming on to the next question, here we have question number 16 from the handout, which is January 2014 C3, question number 2, part A. Okay, so the question is saying that fx is equals to 15 divided by 3x plus 4 minus 2x divided by x minus 1 plus 14 upon 3x plus 4 times x minus 1, where x is greater than 1. Express fx as a single fraction in its simplest form. So first thing first, we are going to take the LCM. So the expression which is being exactly repeated will come once. Okay, 3x plus 4, 3x plus 4 is repeating. It will come once and then multiplied by this x minus 1, and x minus 1 is also repeating. So x minus 1 will also come once. जो expression repeat हो रही है वो exactly एक मर्तबा आएगी. I have discussed this thing in almost each and every question which we have solved, okay, in the class and in the lecture as well. So LCM is going to be 3x plus 4 multiplied by x minus 1. And now you need to ask yourself by what term we multiply 3x plus 4 such that we get this complete expression. Obviously, you multiply it with x minus 1. So the numerator 15 is also be going to multiply it with x minus 1. And then we have the subtraction sign. Okay, and then we need to ask ourselves by what term we multiply x minus 1 such that we get 3x plus 4 into x minus 1. Obviously, we need to multiply it with 3x plus 4. So the numerator 2x will also be multiplied by 3x plus 4. Okay, and before that, we have the subtraction sign. And 3x plus 4 into x minus 1 will be multiplied by 1 such that you get this complete expression. Okay, so the numerator 14 is also be going to multiply it with 1. So 14 as it is. All right, the numerator will also be going to multiply with 1. So 14 into 1 meaning 14 as it is. And now we are going to, expand the numerator first. So 15x minus 15 minus 6x square minus 8x plus 14. So this gives you minus 6x square plus 7x minus 1. After the simplification of the numerator, you got minus 6x square plus 7x minus 1. And this is divided by 3x plus 4 into x minus 1. So first thing what I can do now is make the coefficient of x square positive in the numerator and then factorize it and then multiply the minus sign with any one of the factor which is remaining obviously. So first of all, I took the minus sign outside. I pulled this minus sign outside. I took minus sign as common, multiplied by 6x square minus 7x plus 1. And this is divided by 3x plus 4 into x minus 1. Now you can use your calculator equation mode, the function mode, and solve the polynomial with a degree of 2, and you obtain your roots, and then you obtain the factorized form. So after this very step, you can directly come onto this step. That's perfectly fine. You will get your method marks. However, my usual practice is to, factorize the expressions manually as much as I can. Okay, in the least time possible. So I did factorization steps for 6x square minus 7x plus 1. So 6 times 1 is 6. And after addition, we need to get minus 7 in between. So 6x square minus 6x minus x plus 1. So taking 6x as common multiplied by x minus 1. Taking minus 1 as common multiplied by x minus 1. So x minus 1 into 6x minus 1 is the factorized form. But remember that this minus sign was pulled out. This was taken as common. So taking minus sign as common, multiplied by x minus 1 multiplied by 6x minus 1. And this is divided by 3x plus 4 into x minus 1. So x minus 1 and x minus 1 got cancelled out. Okay. And this minus sign is remaining. in the numerator. So minus sign will be multiplied by 6x minus 1. So this will give you minus 6x plus 1, which is the same way of saying 1 minus 6x. Therefore, fx is equals to 1 minus 6x divided by 3x plus 4. Even you can leave your answer in this way, that fx is equals to minus sign multiplied by 6x minus 1 divided by 3x plus 4. That is perfectly fine as well. Unless a required form is asked, then you need to leave your answer in the required form as it is. Here, no specific required form was asked, so you can leave your answer in equivalent forms as well. So therefore, fx is equals to 1 minus 6x divided by 3x plus 4. This is supposed to be your answer. All right, so I hope you have copied down this much page. All right, I'll just take a short break for Azan. Azan is happening. So after a few minutes, I'm going to continue the recording. All right, so resuming now after a break. Up next, we have question number 9 of the handout. Okay, and this particular question I intentionally did not give in the homework because I need to discuss this concept of ln. Okay, ln is officially introduced, ln, the natural logarithm, is officially introduced in P3 of International A-Level Edexcel. However, though the students who have studied P2 from me in AS, each and every year when students study P2 from me, I always explain the concept of ln and lg. So though the students who have studied P2 from me, they have the privilege of knowing that what is ln before actually starting P3. Okay, because ln is officially introduced in P3, all right, in chapter number 5 of the textbook. But though the students specifically who have studied P2 from me, majority of the students who are enrolled right now, they have studied P2 from me, so they are well aware of this ln concept in logarithms. Okay. However, there are few students who have not studied P2 from me, so that's perfectly fine. I'm going to treat all of them equally. I'm going to elaborate this concept briefly about ln and linking your concepts with P2. Okay. So obviously, my job is to explain each and everything in detail. However, ln will be officially, you know, covered and introduced in chapter number 5 of P3. Okay, so just for the explanation, just for the sake of explaining this question, I am going to give a brief overview about this natural logarithm concept, which is known as ln. So first thing first, part A. In part A, we need to simplify this expression fully. Okay, so first thing first, I'm going to handle the numerator individually. I'm going to handle the denominator individually. So factorizing the numerator, so 2x square plus 10x minus x minus 5. Okay, so taking 2x as common multiplied by x plus 5, taking minus 1 common multiplied by x plus 5. So x plus 5 multiplied by 2x minus 1. And then factorizing the denominator, so x square plus 2x minus 15. So after subtraction, we need to get 2 in between. So x square plus 5x minus 3x minus 15. So taking x common multiplied by x plus 5, taking minus 3 as common multiplied by x plus 5. So therefore, x plus 5 multiplied by x minus 3. Okay, so now we can say that, x plus 5 multiplied by 2x minus 1 divided by x plus 5 multiplied by x minus 3. So x plus 5 got cancelled out, eliminated, intaqal. So 2x minus 1 divided by x minus 3. This is the answer of your part A. All right. So that is basically the whole idea. So that is basically the whole scenario in part A, which is going on. Now in part B, given that ln 2x square plus 9x minus 5 is equals to 1 plus ln x square plus 2x minus 15, where x is not equal to minus 5. Find x in terms of e. Okay, we need to find x in terms of e over here. So first thing first, I'm going to give a brief overview about ln, the basic concept of ln. ln is basically known as the natural logarithm. Okay, so ln is basically the same thing as saying log with the base e, or you can say log to the base e. In place of ln, you can write log to the base of e, where e is basically a specific number between 2 and 3. In your calculator, if you put e raised to the power of 1, so you are going to get 2.71828 and so on. Just put this thing in your calculator. Okay. Shift. First of all, you press the shift button and then ln. So e raised to the power something. So write e raised to the power of 1. So 2.718281828. Okay, this is an exact number, between 2 and 3. All right. ln will be officially introduced in P3. However, those students who had the privilege of studying P2 from me, they know the concept of ln. However, there are few students in my online classes who have not studied P2 from me, and for the purpose of this recording, most probably I'm going to make this lecture public on my YouTube channel as well. So those students who are not aware of ln right now, at this point when they are solving the past paper questions of chapter number 1 of P3, so for the sake of explaining to everyone, I'm just mentioning the basic concept. So let's say if you have a basic logarithmic equation, ln x is equals to 2. So this means log to the base of e argument x, this is equals to 2. So x will be equals to e square, because the base of the logarithm becomes the base of the index form. Since you are studying from P2 that when you have a basic logarithmic form and you want to convert this into an index form, so log with base a argument y is equals to x. So when you convert this logarithmic form into an index form, so y is equals to a raised to the power of x. What you need to remember, that the base of the logarithmic form becomes the base of the index form. Okay, so log to the base of 4 argument 16, or you can say log with the base 4 argument 16, this is equals to 2. Okay, so this means that when 16 is made the subject, when argument of the log is made the subject, so 16 will be equals to 4 square. The base of the log, which is 4, this will become the base of the index form. 16 is equals to 4 square. Everyone knows, even a child knows, 16 is equals to 4 square. But if you want to convert this index form into a logarithmic form, so again, the same rule, the base of the index form becomes the base of the logarithmic form. So log with base 4 argument 16, just put this thing in your calculator, you will get 2. And by without using calculator, we also used to see in P2 that how without using calculator we can get this thing equals to 2. Okay, by using the power law as well. Okay, because in place of 16 we can write 4 square, and according to power law this 2 will come down, so this will become 2 multiplied by log with base 4 argument 4, and log to its own base is equals to 1, so therefore 2 times 1 is 2. These things we used to cover in P2. Okay, now the same rules I'm going to apply on ln. You just need to remember the fact that in place of ln, you have log to the base of e, where e is basically an exact number between, 2 and 3. E is a number which is between 2 and 3. Okay, so ln x plus ln y, if you use the product law of logarithms over here, so ln is the same thing as saying log to the base of e, and terms are being added, so same basis terms are being added, so according to the product law of logarithms, arguments will be multiplied. So this is exactly the same thing as saying ln x into y, the argument is x into y. However, when you have ln x minus ln y, so this is the quotient law of logarithms. Okay, so ln x over y, the argument is going to be x divided by y. All right, this is exactly the same thing as saying log to the base of a argument x minus log to the base of a argument y. This is exactly identical to log with the base a argument x divided by y. This you have studied in P2 as well. Agreed or not? Same concepts are being applied. Okay, so ln is basically the natural logarithm and lg is basically the common logarithm. Lg is known as the common logarithm. Okay, this means that log with the base 10. Log with the base 10. We used to discuss this thing in P2 as well. So let's say LGX minus LGY. This is exactly identical to LGX over Y, meaning the argument over here is X divided by Y. And LG is basically same as saying log with the base of 10. And one other way of writing LG is to simply just use this function in your calculator, log. Log with an open bracket. You can identify this thing. Shift, and then I have a button. On the top, I have just mentioned log. On the top of the button, only log is mentioned. So in your calculator, you get this thing, log with an open bracket. Now, whatever you write in this, okay, so let's say in my calculator, I write log with argument 4. The value is 0.602. Now, this is the same thing as saying LG4. This is the same thing as saying LG4, meaning log with the base 10 argument 4. Now just put this thing in your calculator. Allah ki kasam 0.602 aayega. Wallahi, you are going to get 0.602 over here. Just put this thing. Log with base 10 argument 4. Same thing, 0.602. So this is basically the whole concept of LG, which is a common logarithm. Anyways, we used to discuss these things in P2. Okay. And now here we are discussing in P3. My usual practice is to always discuss ln and lg both in P2, okay, so that we carry those concepts in P3. However, ln is officially introduced in P3. All right, so coming on to this solution of part B. Okay, so here we have the equation. So first of all, I collected the logarithmic terms on one side. Okay, so ln 2x square plus 9x minus 5 minus ln x square plus 2x minus 15, and this whole thing will be equals to 1. Now I'm going to use the quotient law over here. So these two arguments are going to be divided like this. Okay, so ln and argument is basically 2x square plus 9x minus 5 divided by x square plus 2x minus 15, and this whole thing is equals to 1. And now as we can see that in part A, in place of this expression, we can exactly write, 2x minus 1 divided by x minus 3. Okay, we don't need to repeat the same steps of part A. Make sense? All right. So this turns out to be like this, ln 2x minus 1 upon x minus 3, and this whole thing is equals to 1. So in place of ln, I've mentioned log with base e, or you can say log to the base e. So log to the base e argument 2x minus 1 divided by x minus 3, and this whole thing is equals to 1. So therefore 2x minus 1 divided by x minus 3 is made the subject of the equation, and this base of the logarithmic form, which is e, it will become the base of the index form. So 2x minus 1 upon x minus 3 is equals to e raised to the power of 1. So therefore I'm going to say that 2x minus 1 is equals to ex minus 3e. Okay, so collecting the terms in x on one side, because we need to express x in terms of e. So I need to make x the subject over here. Okay, so 2x minus ex is equals to 1 minus 3e, taking x as common, multiplied by 2 minus e, and this whole thing is equals to 1 minus 3e. Therefore, x is equals to 1 minus 3e divided by 2 minus e. Or you can alternatively write your answer in this way, that if you take the minus sign as common in the numerator as well and the denominator as well, so minus minus will get cancelled out, and this will become minus 1 plus 3e, and this will be minus 2 plus e. So therefore x is equals to 3e minus 1 divided by e minus 2. Anyways, both of these forms are perfectly fine because a specific form is not required over here. All right, so this was the solution of this question. Okay, I hope you have copied this much working. So now let's move on. So up next, we have another question, which is question number 18, June 2015, C3, question number 9, part A. All right, so given that k is a negative constant, and that the function fx is defined by fx is equals to 2 minus x minus 5k into x minus k divided by x square minus 3k x plus 2k square. where x is greater than or equal to 0. So the requirement is to show that fx is equals to x plus k divided by x minus 2k. Okay, so first thing first, we are going to express this as a single fraction. Okay, 2 के नीचे कुछ भी नहीं है तो 2 के नीचे 1 तो है. Okay, meaning in place of 2, I can write 2 divided by 1. Okay, so if I write 2 in a fractional form, so this will be 2 over 1. And when I'm going to take the LCM, so LCM would be x square minus 3kx plus 2k square. Okay, and then, we need to ask ourselves, 1 will be multiplied by what, such that we get this complete expression. Obviously, x square minus 3kx plus 2k square. So this numerator 2 will also be multiplied by x square minus 3kx plus 2k square. Okay, and then we need to ask ourselves that by what term we multiply x square minus 3kx plus 2k square such that we get this complete thing. Obviously, we multiply it with 1, so the numerator will be multiplied by 1, and here we have the subtraction sign in between. Now, what I'm going to do, I'm going to expand the numerator over here. So 2x square minus 6kx plus 4k square and then subtraction sign. And I'm going to expand this x minus 5k multiplied by x minus k. So x square minus kx minus 5kx plus 5k square. And after simplification, I can see that, 2x square minus x square will be simplified as x square. And one more beautiful thing happened, that minus 6kx and plus 6kx got cancelled out. Okay, because minus kx minus 5kx would be simplified as minus 6kx, and this will be multiplied by this minus sign, which will become positive 6kx. And wonderful thing happened, the term in x got cancelled out. The terms in x got cancelled out after simplification. Okay, so जब चीजें cancel out हो रही होती हैं तो बहुत अच्छा लगता है ना. So that's the thing. When things get cancelled out, it looks good. Okay, wonderful. And 4k square minus 5k square, which is minus k square. Okay, so x square minus k square divided by x minus k times x minus 2k. Here I obtained a factorization form. Now, due to these type of questions, my usual practice is to always factorize the quadratic expressions. Okay, so that you don't get confused. Okay, so here I've done some extra piece of working in order to factorize this x square minus 3kx plus 2k square, just to give you a brief overview about this. So, if you knew the value of k, फिर तो कोई issue नहीं था ना. If you knew the value of k, then it would not be an issue. However, k is unknown, and we need to obtain a factorized form in terms of k. Okay, these types of factorization we also used to do in P2 in the proof questions specifically. I hope you all remember. Okay, so x square minus 3kx plus 2k square. So 1 times 2 is 2, and after addition we need to get minus 3 in between. So minus 3kx would be broken down like this: minus kx minus 2kx, such that after addition we get minus 3. So minus kx minus 2kx will provide you minus 3kx. Okay, so taking x as common multiplied by x minus k, taking minus 2k as common multiplied by x minus k. So therefore x minus k multiplied by x minus 2k. This is the fully factorized form for the denominator which I obtained over here. Okay, so here is the working. So now, x square minus k square is basically a difference of squares. So this will be factorized as x plus k multiplied by x minus k. And this is divided by x minus k into x minus 2k. Therefore, fx is equals to x plus k divided by x minus 2k, because x minus k got cancelled out. And therefore, congratulations, you have obtained your required form. Fx is equals to x plus k divided by x minus 2k. Here we have shown this form. All right. So for the purpose of this particular lecture, I have discussed 4 past paper questions over here. Okay. And this was part 1 of lecture number 1.5 of International A-Level Edexcel P3. And now I'm going to take just a short break for dinner, and then I'm going to record further 2 questions. 2 questions are left to be discussed. Okay, so for that I'll make a separate recording. January 2023 question number 4, and January 2024 question number 4 as well. The part is of those questions. Okay, so for the purpose of this recording, I've discussed 4 questions. Inshallah, I'll be, you know, uploading this lecture, inshallah, most probably as a public video on my YouTube channel along with the timestamps. Okay, so what we can do is, for the purpose of public videos, we can keep the number of questions, restricted per video. In the last year, I, kept 2 to 3 questions per video. In many cases, 2 questions per video to keep the videos brief, to the point, and uh, easy for students to absorb, comprehend, solve, learn, connect. Okay, so 4 questions are maximum, they are fine, because the questions were quite brief. Obviously, when the questions require more explanation, so I can reduce the number of questions per video. So 4 questions in this video. Inshallah, next video, part 2 of lecture number 1.5 will be shared separately. Stop recording.